So, thanks a lot for having me and giving the opportunity to give a little bit of an account of what has been going on over the last year. It feels just right to follow up on Bart, and of course, this wasn't really arranged, but it makes sense that is in fact happening. So I wanted to start my presentation by playing the video that we proposed that as part of the Montenegro Pavilion and the Venice Biennale. This is not just because it's an important project, but I think also in many ways influenced us beyond this project itself. I think the whole way Bart curated that exhibition and also the way in which we approached the problem became for us something we wanted to try to pursue further and also to seek other opportunities. And of course, Tallinn just happened to follow, and it seems just the right kind of opportunity. So very quickly I play the video, and then after I'm going to speak again. The Sentinella is right now above us, scanning the landscape of the Salina in Rossini and sending data to the ground station in Matera. The Sentinella 2 has got a wide range of sensors that are able to capture different wavelengths. Interestingly enough, you can algorithmically select different wavelengths and calculate or compute a series of drawings or maps that may allow you to see this landscape and the gradients and that are characterizing it. Is this the way birds see the landscape? Ornithologists are actually able to track some of the species that come to Solana through GPS trackers that they install on the back of some of these animals. And so the birds have become data feeds. From this perspective, the Salina really appear as quite small. But if you zoom in, it could be nice to imagine the surface of the Salina to corrugate, to become a lot more articulated. So imagine machines that operate more in the way birds operate, through swarm-like behavior. Maybe simpler machines or smaller machines that would be able to coordinate and to begin to develop behaviors in the shaping of the landscape, for instance, some kind of ground machines or ground robots. It would be interesting to imagine how this can be embodied in architecture in the form of these aviary that are open because don't have a net, but that create conditions for nesting and for interaction beyond what we know today. As you look at the crystals of salt right now, you can imagine these patterns to be affected by these emerging morphologies. Yes, and perhaps this whole process can be detected from the satellite itself. So this was our proposal, or part of our proposal there for the project Solana Uncini, and of course the site we engaged with has a very peculiar characteristics which were illustrated beautifully by Bart just before me. But as Bart mentioned, we ended up zooming in and out from the scale of the salina itself to actually capture what we felt were some of the most interesting ingredients. And of course, the birds and the ecosystems that supported them were obviously one of the key themes. And we understood that their framework was much larger than the salina itself, not just because they were migratory birds, but also because the salina was part of a larger ecosystems and regional ecosystems. And so we started this collaboration with ESA, the European Space Agency, which has just launched very sophisticated satellites which enable, let's say, the scanning of the landscape, a very high resolution, but it's not just the resolution, it's the specific kind of sensors they have which enable to detect substances on the landscape which may be microscopic in scale, but that contribute significantly to the character of the biotopes itself. So we began to see the reality in which we live and in which the site exists as something that really fluctuates from a very large to the tiny scale. And of course, this has a kind of very strong implication in the way we understand the landscape, not just as a kind of a natural biotope, but also as this sort of a hybrid of man-made infrastructures and let's say, natural ecosystems. And it was very intriguing when we started to get involved with Tallinn, and with Claudia, we started to explore the city and to try to understand how to, let's say, situate this biennale, that we came across with a very specific place, which is the peninsula of Pagliasare. I hope it's actually pronounced in that way. But the peninsula, it's obviously very different from Solana. It's a completely different climate and, if you want, biotope. But it was kind of, on one side, bizarre, but also exciting to find that the few people that were, in fact, attending the peninsula and actually regularly going there were bird watchers. And the reason for that is because, of course, there is the tip, especially the tip of the peninsula, has grown or regrown after the Soviet military base left to become a host of different species. And the even more intriguing fact is that some of the species that we find here come all the way from the Mediterranean and possibly also from the site in Solana. So we could argue that although we are in two completely different ecosystems, there are actually physical links that bring these together, which again brought us to this idea of the necessity to zoom out and to consider the city at a larger scale. Of course, many would argue that this peninsula is actually marginal, so we should not even consider it as an urban territory, but in fact, the peninsula is dominated by the wastewater treatment plant of Tallinn, right? We are not really used to talk about wastewater treatment plant that much in architecture or urban design, but in fact, from the perspective of wastewater, the peninsula of Pagliasare is actually the center of the city of Tallinn. All the wastewater converges to that point, to that location. So again, we found that particularly intriguing because that meant that the peninsula in itself has these kind of characters, these characteristics that we already found in Solana, and that in a way also end up being particularly problematic. And when we had the opportunity to meet with the city council here in Tallinn and to do more of the research, the background research, we realized that in fact already a few times there were attempts to develop this peninsula, to turn this peninsula into a kind of more active urban area, and this attempt failed because of the challenge to reconcile these terrains, the sort of infrastructural and, if you want, the ecologic or the natural. So we said, how can we use our project or our biennale to somehow shift perspective. We think that within the conventional perspective, there is no solution to this conundrum. So we said, okay, what kind of perspective we can find that maybe would enable to reimagine the peninsula and to actually turn it into an active terrain. And so the beginning was really much a kind of a research-based time. We spent time really digging for data. There is a lot of information about the area, even zooming out at the scale of the Baltic Sea. This is an image that we found on the database that really describes some of the aspects of the Baltic Sea, in particular the depth of the sea. And one of the qualities of the Baltic Sea is that is a rather shallow sea. So although is very large in particular areas, especially around Tallinn or this part of the sea itself, the shallowness makes it very sensitive to anthropologic impact. And so we realized that already now there are a whole series of transformations which are affecting this part of the sea, which make it itself not a sort of untouched, untamed body of water, but a rather kind of artificialized condition. We then zoomed in the scale of the city of Tallinn itself. Again, continuing our collaboration with the ESA, we started to capture a series of visions of Tallinn, and not only Tallinn itself, but really the peninsula and the surrounding body of water at increasing resolution to try to understand the kind of exchanges and implications of this particular terrain. You can see right in the middle of the peninsula is the wastewater treatment plant, which is expanding. On the right, you see in the center are the body of water of the treatment, and on the right there is this expanding yard where all the sludge and the outcome of the plant is beginning to spread, and it's somehow pushing the line of the natural reserve further up. In the center is a lake, which is the remnants of the old wetland, which is getting more and more grown up and contaminated with the effluent of the water treatment plant. And so again, the friction between conservationists and the city pushing in really has a pretty clear line that you can see right in the middle of the peninsula. So we started to think about how we may be able to redefine that line. That line is clearly a conflictual line, is a line that has no solution. And so we tried to begin to analyze the landscape through this process of scanning of on one side, the infrastructure. So we started to abstract the city of Tallinn itself. This drawing depicts the city from the point of view of the wastewater infrastructure. But also, slowly we started to propose visions and drawings that would dissolve this line and would redescribe the peninsula as a kind of distributed wastewater treatment landscape. So these images started to let's say, inform, of course, our own contribution as ecoLogicStudio to the Biennale, but also we sort of used this as sort of research material that we offered to the other participants that Claudia was engaging with. And so somehow the idea was to in a way, set up a collaborative project where very specific informational material was shared and would, of course, influence and trigger other groups to come up with their ideas. We then went zoom in into the peninsula scale, and we developed a series of maps that were engaging with the wildlife aspects of the project. So from the infrastructure, we moved into looking at different species of birds and plants and other animals that are inhabiting the peninsula. And then we started to describe the tip of it, the part of the peninsula that is, let's say, threatened by this contamination process through a kind of digitalization of it. So we started from very simple descriptions of the wetness. It's interesting to remember that this area, now we call it peninsula, but originally these were in fact two islands that were connected by a wetland area, which has been gradually filled up by material, mainly man-made material, but there are also natural processes involved. And so gradually this accumulation has dried the area and connected the peninsula to the land. And so we started to try to read and understand this pattern and perhaps also recuperate some of the kind of original tendencies or the sort of morphology of this wetland. And these drawings are mainly research material, but also informed quite specifically the way we wanted to approach the task of the project. And so these are drawings that on one side describe the area from the wetness point of view, but also that begin to depict this idea of a kind of distributed wastewater treatment system. So the idea of a kind of percolation water and how that could begin to define the sort of planning or the organization of the peninsula in the future. So some of these drawings are really exploring the intersection between these natural processes of water percolation and the infrastructure that is necessary to deliver the water into this location. So again, the sort of reimagining of the wastewater treatment as we know it today. And this is one of the panels that we also proposed for the exhibition. It's part of the curated exhibition, and that again describes, let's say, these new habitats that we imagine really as a sort of interaction or interference between existing wildlife habitats and new infrastructural canals or developments. And so the idea again is we're not like proposing a solution or definitive solutions, but rather a framework for this interaction to develop and to find different ways of evolving. The second part of our project was really to explore how this very diagrammatic level may be materialized, of course, as a landscape, as a kind of morphological articulation of the land. This is one of the images we sort of developed, and is very much seen as a kind of top view image, but is of course beginning to explore an articulation of the landscape into plateaus and channels or valleys. And of course the plateaus and the valleys are connected by this striation of the land itself. The striation, we can call it water treatment canals, but effectively we understand them as a more complex and articulate entities. The colors here are trying to describe that complexity. So the purple symbolizing the untreated sludge, whereas the green symbolizes the kind of habitat, the natural habitat. And of course the sort of gradient zone in between are where these negotiations are happening. We also explored different views of this, beginning to engage with the idea of time, and especially here in Tallinn, these really strong fluctuations of weather, and going from almost like a frozen landscape in the winter to a kind of warm and sort of wet condition. And so we began to try to imagine this landscape also as one that would be constantly kind of flooded and dried and would host life in different forms across these gradients, with obviously some of the plateaus being constantly dry areas and where the deeper canals being constantly wet. This is a kind of future satellite view. We then moved into producing a model. We wanted to explore how we could turn all these rather abstract or informational landscape into a more tangible material one. And so we tried to play with this idea of resolution, articulating every pixel of the image into a different high, if you want, of a kind of a datascape. And so we wondered what kind of massing we would get out of this exercise. exercise. And I have to say that this process was also very much driven by a kind of a speculative idea of landscape that would somehow capture qualities of what a future city may be, but at the same time also be quite open to interpretation and to sort of evolution of these conditions. These are iterations that we proposed and that we went through, and finally we reached the stage in which we entered a more kind of production-driven moment. We decided we were going to materialize this landscape in the large model that you will see in the exhibition, and this large model is pretty much a massing model, but we didn't want the model to be just a surface. So the idea is that we are actually designing a thick layer that exists in between the bedrock and the air, if you want, the microclimate. So this thick, rich layer is very much informational, but also has material quality. And so the game we played with this model was to take this very abstract approach and see how we could begin to extract materiality from it. So if you look at this, this is a rendering, this is a picture of the model that you see in the exhibition, and if you look at the model from the side, it's almost pure data. It's completely abstract. You only see these lines of information, but and in a way they can be understood as quite generic. But obviously when you turn upside down and we start to look at it from the top, and especially zooming out from a certain distance, materiality emerges. And what was kind of fascinating for us was really to try to harvest these material qualities. And again, the idea is that the approach to the model itself, the model becomes also an experimental laboratory. We didn't want to have a preconceived idea of what it would look like, but we tried to obviously play with this notion of a soil, of a earth, of a ground, a nutritious ground, and on the other hand, the sort of heavily digital informational structure underpinning it. So we tried to get to the point in which these two qualities would alternate or fluctuate depending on how you look at the model. And this is a view from a little bit further away of the model. There are 4,000 sections that compose the model itself. Each section is made of a large number of points. I think altogether is around 4 million pixels that create the articulation of the model. And this is a picture from above. It's taken very quickly last night, so I apologize if it's not the best quality, but I invite you to go and see it live. But you can see how, from this perspective, something quite interesting happens. It almost becomes dynamic, and to our idea, I begin to engage materiality on a different level. Again, this is all quite fresh in my mind, so I just offer to you the process. I don't really want to comment too much about it. We also went a little further and tried to speculate how this landscape may, in the future, evolve and grow into multiple layers that articulate space and more, let's say, complex, inhabitable landscapes. And again, these are driven by the idea of integrating infrastructure with living units. And this, of course, proposes how program may be understood as a kind of differentiation of sites and microclimates and orientations, rather as a kind of zoning or top-down programming of the space itself. And this is one of the final images we have proposed for the project, which is really about this kind of future landscape, possibly 20, 30 years in the future, after multiple cycles of manipulation and growth, and perhaps also decay and shrinkage in certain part of it. And of course, we also want to imagine that within certain bubbles, new climatic and microclimatic conditions may emerge, to the point in which the ecosystemic palette of the region, of the area, may even be expanded. This is a little 3D printed model you will find in the show that also tries to engage this. And again, the two colors, the two materials describes what we understand as infrastructural and what we understand as biological, and this kind of interrelation between the two. But I mean, this to a certain extent may sound also a little bit kind of fictional or wishful thinking, if you want. But what I want to close my presentation with is just a little quick overview of some of the work that we have been conducting with my practice, ecoLogicStudio, in the last few years, that really takes some of these visions and to a more actualized stage, I would say. So we have been engaging with this idea of living bioreacting skins or bioreacting architectures, and we have developed a series of prototypes, which in this case are very much engineered and driven by the wish to test in one-to-one these ideas. And so to offer almost like a kind of a very concrete, very pragmatic counterpoint to this more speculative work that I just present you. So this is the one we presented in Milano 2 years ago for the Expo. So we started this collaboration with Expo already in 2011, but we ended up developing this particular prototype. I also want to stress that even the most pragmatic projects that we do always start with the phase of drawings, and in this case the drawings are not necessarily just a way of describing pretty images. It's really this necessity for us to try to find a way to articulate infrastructure and space within the similar matrix. It's rather difficult because typically infrastructural systems talk a different language and are also dealt in a different moment in the development of an architectural project. We try to move this phase right at the beginning, and I think you will see some of these kind of approaches are very interestingly represented in the exhibition here. But in this particular project, so the piping, the sort of distribution system of what is a fluid containing microalgae, so a photosynthetic fluid, was really informing the project, which then was developed as a pavilion that you see here. Maybe I play a little video to just capture the kind of dynamic qualities of this idea. My name is Poletto from ecoLogicStudio in London. We are artists and architects, and we are here in Expo presenting the urban algae folly. The Urban Algae Folly is an interactive pavilion for the urban cultivation of spirulina. It's a built demonstration of architectures by a digital future. The particular aspects of our project is to bring the cultivation of microalgae within the urban environment. This is a public space where the folly operates at different levels. On one side, it creates a particular condition for visitors to rest, to be shaded by the algae, by the canopy and the microalgae themselves, and also to find refreshment in the evaporative cooling of the pavilion.
The urban algae folly produce an average of 2 kg of oxygen per day, which is the equivalent oxygen that 3 adults need to survive. It takes 25 large urban trees to do that. The folly produce the equivalent in proteins of 2 kg of meat per day. The folly also captures CO2 at a rate of 4 kg per day. All this is happening in the public realm. This is the key idea of the project, embed production in the urban realm.
Algae really challenge us to understand nature really as part of an infrastructure, what we call a biodigital infrastructure of the city. Our vision is that the convergence of information and biological technologies can create the possibility for a new industrial revolution, for the creation of a new city, of a new urban environment. So this was one of the videos we produced for the expo itself. But I think what is interesting here is that what we tried to do in this project was really to bring kind of fundamental ideas and principles that we discussed also in this Biennale to a larger audience. Of course, the expo is a really large event which is not concerned essentially only with architecture. In fact, in this case, was very much about the future of food and feeding the urbanizing population. And so, but for us, it became really an opportunity to test how these ideas could be embedded into a larger framework. And following the Expo Milano, we went on with this line of inquiry as one line of inquiry. So we developed a series of pieces that would work to really test these ideas in different cities, in different urban environments. So one of the outcomes was this pavilion, which pretty much deploys a similar system of ETFE photobioreactors, but it is embedded into a kind of urban sculpture, public sculpture, which is dismantleable and disassemblable pretty easily and quickly can be transported. And so it becomes a kind of itinerant test bed. And this is one of the last opportunities we had to exhibit it in Aarhus this year in Denmark for European Capital of Culture. This also became the excuse to start a collaboration with the city of Aarhus in developing and helping them to develop their new blue-green master plan. So again, this is slowly really moving into a much more actualized phase where we engage the administrations of cities and we try to bring ideas that may sound far-fetched to a certain extent into the reality of planning of future cities. And this is just images of it as part of the harbor area of Aarhus. Whereas this is another instance in Portugal, in Braga, where we installed it at the end of last year. So very quickly to conclude, again, this inquiry brought us to Expo Astana just now, in fact. This is the biotech hut, which is another iteration into this idea of living architecture. It's not a sort of a pavilion, but it's understood more as a kind of living unit. So if you want, you could see this as a first iteration on how one of those bubbles, little bubbles that we modeled in our proposal here as a kind of prototype of that, a unit that hosts bacteria, microorganisms, different type of systems, and of course creates an environment where humans can interact with this in a I would say more in a deeper way and in a more efficient way to a certain extent. So the pavilion was organized in 3 environments, one called the lab, living, and garden. The 3 environments had a different, let's say, way of engaging with this micro world, the lab being the kind of scientific, rational approach, the living as being the sort of experiential, intuitive, artistic approach, the garden, the craft, the hands-on, the production space. The system, in this case, was based on glass tubes manufactured in the US and assembled by a Dutch company which specializes in this system. And we obviously were the first one to articulate this tube within a kind of spatial framework that is not, let's say, just a kind of linear production system of an algae farm, but really that can be embedded into the fabric of architecture. And as you can see, we tried to articulate the space of the hut also to, let's say, incorporate the system and the way the systems are functioning. So again, the plan, the organizational principle of the hut also, in a way, organizes the flows and the systems that describe its functioning. This is one of the plans, and this is the actual place. This is our scientist in residence running the lab show there in Astana, engaging a varied audience in different kind of experiments. This was really about opening up this micro world, which we know very little about, but that, of course, scientists are engaging with more and more. And this is the centerpiece, which we also produced, which is a kind of living sculpture that allows users to immerse themselves into this cloud of cyanobacteria, and also to feed them with their CO2 exhale and to breathe the oxygen. So it's a way to induce a more experiential kind of symbiosis with this, between man and these kind of organisms that are still so far away from our sight, and even more so from our daily experience of cities. This is another image, and this is from within. And these instead are the glass pipes of the main algae farming system, which becomes very dense in the garden area, and especially converges into these tanks, which are the center part of the hut, and that's where the harvest occurs, and so that's where the biomass and the cyanobacteria can be extracted and turned into food or biofuels, depending on the species. This is it for me today. Thanks a lot for having me again.